Welcome to our next lesson, and in this one we're going to be learning about loops, which is a control flow structure in Python that allows us to do something over and over again, and we can give it a criteria to stop. So I'm going to go ahead and create a new file here, file new, to Python, call this one loops.py to make it a Python file. Okay, so a loop can have different forms, but we're going to cover the first one, which is a while loop. Just like that, you can type in while. And just like our if statements, this is going to have a condition. And this condition is going to determine if the loop executes or not. So I'm just going to say while true here. And then I'm going to print out a message. I'll just say looping. All right, so this is our conditional. It says true. Our loop is going to check to see what the condition is, true or false. In this case, true. And then it's going to print out looping. It's going to do the inside of the loop here. And notice that this is tabbed over. Whenever we're in Python, just like with if statements, and we have a control flow structure here, like a while loop or an if statement, to put something inside of that, we have to tab it over. So if you kind of missed that on our if statement lesson, this is what we need to do. This is inside the while loop when it's tabbed over like this. If I tab it over like this, remove that tab actually, now it's not inside the while loop. This is outside the loop. This is inside, and this is outside. So this loop checks to see if the condition is true. The condition is true. So on line 2, it prints out looping. And then after the loop is done executing the first time, it comes back to the top line, the while loop, and it checks to see if it's still true. And because I set this to true like this, it's always going to be true. So that means this loop is always going to run. And this loop should print out looping forever. So I'm going to go ahead and save this. I'm going to jump back to the command prompt, type in Python, and I'll make this bigger so you guys can see it easier. And then I'm going to type in LO and hit tab, and that gives me the rest of what I need for that name, which is loops. Hit enter. And it's looping forever and ever and ever and ever and ever. You can see down here it's kind of stuttering because it keeps printing this out as fast as the computer allows it to print. So right now this program is going to execute forever. So to stop this program, I'm going to press Control-C, and that will kill the process that is running in this command prompt. Okay, so we'll jump back over here. So infinite loops typically aren't extraordinarily useful. They have their uses, but let's say you want this loop to stop after a certain amount of time. Let's say you want this loop to only execute 10 times. Then what I can do is I can create a variable. I'll say this is called max loops. Set that equal to 10. I'm going to create another variable, and this variable is going to keep track of how many times the loop has executed. I'm going to call this counter because it's counting the amount of times the loop is executed. So I'll say counter. I'm going to set it equal to 0. I'm going to start counting from 0. All right, and now if I want this loop to stop after 10 times, I have to use these two variables in my loop. So here I'm going to check to see if my counter is less than max loops, because we only want this loop executing if counter has not reached the maximum amount of times. All right, last thing we got to do is we have to count each time the loop executes. So at the end of my loop, I'm going to say counter equals itself plus 1. And this is saying I have counter, I have my equal sign. My equal sign says whatever's on my left, store it into whatever's on my right. And we have a counter here on our right. And counter right now is 0 first time this loop executes. So my equal sign says, okay, I have 0 plus 1. Then it resolves that and says, okay, I have 1 on my right side. And then it says, okay, what's on my left? I have this variable called counter. Okay, store 1 inside of counter. Update counter's value to 1. And Each time this loop executes, it'll set counter equal to itself plus an additional 1. So basically, every time the loop executes, counter gets incremented by 1. And then once counter reaches a value of 10, it won't be less than max loops. It'll be equal to max loops. And so this will be false. And it should stop printing out. So I'll jump back to my terminal, clear this out. I'm going to run it again. So I'll say Python, and I'm going to say LO, hit tab. That's going to autofill the rest of the name that I need. I can hit enter. And there we go. Let's count. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So print out 10 times. If I jump back to my code real quick, and I can make this conditional statement a little more complicated. Let's say I want to print out 11 times. And I don't want to change this to 11. Let's say I want to keep it as 10. Well, what I can do, I can say max loops plus 1 inside the conditional statement. This is an alternative way that we can run it 11 times versus just setting this max loops value to 11. So I'll jump back over here. I'll run it. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I ran 11 times. So this is controlling our loop, telling it when to stop. There's no way we can do this. And we can make this an infinite loop. This is a use for infinite loops, or a way you can implement infinite loops. We could say while true, so this will always be executing. And then we can put an if statement down here to check our counter, just like we did a second ago, but instead of it being in the while line, it's going to be down here at the end of our loop. So we can check if counter is less than max loops. Sorry, not less than. We'll say the opposite of less than, which is greater than or equal to. If counter is greater than or equal to max loops, we're going to tell the loop to stop. And to do that, we're going to say break. Now, break is a new keyword that you haven't seen yet. And break is saying, whatever loop I'm in right now, stop that loop right here if you reach me. So if break is ever read by our code, it'll stop whatever loop it's in. Now, if I had this loop inside of another loop, it wouldn't stop both loops. It would just stop whatever the closest loop to this break is. All right, so we'll go ahead and run this. Clear this out so it's easier to see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It prints it out 10 times. And we have this while true here. It would be an infinite loop, but we have this check down here that says if our counter, the amount of times the loop has executed, if it's greater than or equal to the amount of times we want the loop to execute, stop the loop. All right, so let's go ahead and explore another style of loop. And this style of loop is called a for loop. So I'm going to go ahead and delete all of this. And a for loop uses the FOR keyword. And this loop is similar to our while loop. It's similar to our implementation where we're counting the amount of times the loops happened and then stopping it. But this is going to do it for us. So if I say for I, and I is my index is like a counter. And to make this less confusing, I'm actually going to just delete this counter declared up here, because this here is the same thing. For counter, I'm going to say in, and I'm going to use a function here. And this is the range function. And this range function is going to take in a number, and it's going to give this for loop an amount of times to execute. So I'm going to say for in range 10, or rather, because max loops is already set to 10, I can just say max loops. Okay, so I'm throwing a lot at you right now. I'll break this down word by word. For is the type of loop, and a for loop has to count the amount of times. It does what we did in that while loop implementation where we counted ourselves, but this is doing it for us. For count, This counter variable is the same as the counter variable that we had before, except we don't have to manually update it like we did a second ago. We said counter equals itself plus 1. Here we don't have to do that. This loop is going to increment this every time it runs for us. This in range section right here, this is saying I have a range and it takes it from 0 up to the number I give them. And so if I give it 10, it's going to give me the range 0 to 10. And this for loop line here, it's going to set counter equal to the first value in the range, which is 0, just like we did a second ago. And then each time this runs, counter gets incremented, and it stops when it hits the maximum value in the range. So essentially, it's doing the same thing that we did for our while loop implementation. If you want to back the video up and check that out, if you don't remember exactly what was happening there. Okay, so I'm going to go ahead and do something here. Let's print a value, and I'm just going to print out my counter just to show that it is updating. It's incrementing, increasing its value. I'll save this. I'll jump back to my command prompt, and I'll run it again. Notice how it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but it didn't print out 10. And the reason why is because this for loop here, it's doing a less than check. So it takes the top value of this range, 10, and it's doing that same while counter is less than 10, which was max loops here. It's doing the same kind of check. And so if counter is 9, it is less than 10, and it'll run. But if counter is 10, it's not less than 10. It's equal to 10. So it doesn't run. Okay, so this is how a for loop functions. And oftentimes, it's a lot more efficient to use a for loop to count and do something a specific amount of times. And so there's a lot of stuff here, but just remember the range is just 0 up to whatever value we give it. In this case, we've given it max loops, which is 10. Counter is just the same thing. It's counting up. And then the for loop is automatically checking to see if it's above the value in the range. Okay, so that's our while and for loops. Now let me show you a practical example for what we can do with loops. Let's say that we want to print out a sequence of numbers. Let's say we want to print out all the even numbers. We want to print them out, well, we want to print out the first 50 even numbers from 2 until we get to 100. Because if you think about it, between 0 and 100, there's going to be 50 even numbers because it's half the amount of numbers. So we should print 2, 4, 6, 8, 10, 12, all the way up to 100. Let me delete some of this. We're going to say max loops. I'm going to set that equal to 50 because I want the first 50 even numbers. And for this, I'm going to use a while loop, and I'll show you how to do it with a for loop. So we'll say while. I need to create a counter manually here for a while loop. It's equal to 0. While counter is less than max loops. Oops. Loops, just like that. Then I'm going to print, and this is where I'm going to print out my value. I'm going to print out every even number. And so to do that, I'm going to take my counter and I'm going to multiply that by 2. And I'm multiplying it by 2 because if you think about it, every even number can be reached if we just take the numbers 1, 2, 3, 4, 5, 6, 7, 8, increase them all, and multiply them by 2. Multiplying 1 by 2 gives us 2. And then when counter goes to 2, If you multiply 2 by 2, you get 4. And if you go to counter gets updated to 3, multiply that by 2, you get 6. So you have 2, 4, 6, etc., etc. So I can do this here, but notice that counter set to 0 first. If I do 2 times 0, I'm going to get 0. And I don't want to put 0 in the sequence. So to make this make more sense, I'm going to say plus 1 here to shift it all over by 1. But then I also have to shift this over by 1 as well. And this will fix that error. So let's go ahead and save this. Let's run it again. Oops, I did something wrong, and I forgot to update my counter. So if you're getting something like this, where you're getting 2 forever, go and stop that. You want to update your counter for sure. Because if your counter is always at 2, or sorry, if the counter is always at 1, that's what it's at now. You can multiply by 2 and that's your output. If the counter is always at 1, then it's never going to become equal to greater than max loops. Therefore, your loop is never going to stop executing. So we're going to say counter equals counter plus 1 to make it where it does update. So I'll jump back over here and we'll run this again. There we go. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And as we scroll down through here, we have all the even numbers printed out up to 100. And that should be 50 values. This is our while loop implementation to print out the series of even numbers. So if you want to look at this and study it, you can pause the video. And I'm going to just go and show you right now what would happen if we didn't shift this over by 1. So I'm going to put a comment here. And if you don't know, a comment will take everything that's to the right of it, and it will not read that as code. It'll just read it as plain text. And so essentially, our code is going to skip over it and not see it. A comment is just for humans to read, not for computers to read. It's like a note that you put in the code, so you can describe what's happening, or so you can like remove some functionality like we're doing here and test it without it. So let's see what happens if I didn't shift it over. We would have printed out 0, which we didn't want, and we would have not printed out 100 because we shifted our whole sequence over by 1 unit. So shifting this over by 1 will print out the correct sequence, just like that. Okay, so that's our while loop implementation. I went ahead and commented out our code here so that we can go ahead and do our other implementation, our for loop implementation of the same thing. And that way, so the computer won't read it as code. This section 1, lines 1 through 5, it won't read it as code. It'll just skip over it and won't read it. All right, so let's go ahead and say for counter in range. And we're going to do the same thing we did for the while loop. We're going to have to shift this over by 1. So I'm going to say 51 here. And unfortunately, the way that we have to trim off 0 in this sequence, we're printing out 2, 4, 6, 8, all the way up to 100. We're not printing out 0. The way that we trim this out is we have to use if statement, which is going to require a little more typing. So I'll say if counter equals 0, the first time this runs, it will equal 0. Then I'll do nothing. I'll just say pass. And this pass right here is letting this if statement do its thing without throwing an error. If I didn't put anything after this colon, Python might throw an error and cause a problem. So I'm just telling it to pass and skip this line so that it has something to look at there. Now, I'll show you what would happen if I didn't do that real quick. I'm going to finish this implementation out. We'll say else, anytime it's not 0, basically. Print what we did earlier, which is counter times 2. And I'll save that. Oops, I did something over here. Let me do that. All right, we'll run this again. We'll say Python loops. And there's the problem. says expected indented block after if statement, which means it's expecting you to give it something to do here. And so to fix this error, if I don't want to do anything, I can just say pass. That's what that pass keyword is. All right, so we'll run this now with the pass in there. And it's taking a second to load, and there it goes. We have 2, 4, 6, 8, 10, 12, 14, 16, et cetera, et cetera, et cetera, all the way up to 100. And so this 51 thing where we had to add one to it, that's just a little quirky thing about code that can happen sometimes. It's called an off by one error when you are off by one loop, one iteration of your loop. And so we put this at 51 to fix that. And we just told the code on the first time run the loop, don't do anything, as in don't print out 0. And that shifted our sequence over to get 2 through 100 instead of 0 through 98. So that's our implementation for and while loops. If you want to play around with this code, do so. Change some of the values. Maybe try different sequences. Maybe try a geometric sequence. You can look that up online to see what that is. Or maybe try a Fibonacci sequence. And that'll be a little bit hard to do. But later on, when we cover functions, we will be doing a Fibonacci sequence. So if you want to go ahead and try to piece that together now, that'd be a good idea. But for a bit of a homework assignment, or just a bit of an assignment, let's go ahead and look at our knock knock joke code. So I'm going to jump over here to my knock knock.py. And we left off where we were putting if statements in here and checking to see if the user input was what we wanted it to be. So I'm going to implementation here real quick because I don't have my if statements in here. So we have print knock knock user input equals input. So after line 2, we've got the user input. So now we need to check it. We'll say if user input. I'm going to say there's 2 ways I can do this. I can say equals who's there, and then I can not this. So I'm saying if the user did not enter who's there, that's the not's doing, then exit the code. I could do something else as well. Instead of putting my not right here, I could have actually come over here. I could put an exclamation point equals. And this is saying does not equals. In mathematics, imagine an equal sign of a line going slash. You may have seen that before. That's saying does not equals math. This is saying the same thing. And it's also the same thing as putting a not in front of the whole statement. And so if it's not who's there, it'll exit the code. I'm going to save this and run this code real quick. So I'm going to clear this out so we can see it. Say Python, say knock knock.py, knock knock, and I'll just say who's there, which is the correct response at first. And jump back over here. Oh, I see the problem. The reason it exited the code is because it's checking for a capital W and a capital T. It is case sensitive. So I'm going to save it, jump back, run it again. It says knock knock. I'll say who's there. This is Kent. All right, so that was the correct input. What if I give it the wrong input? I'll say dogs. And nothing happens because it exited the code. So why am I talking about this when we're talking about loops? Well, for your homework or for this little assignment here, I'd like you to try to, instead of exiting the code, tell the user to try again, to say the right response, and give them an infinite amount of times to try. And then once you get them to give the right response, go ahead and break out of the loop and continue on to the next part of the punchline. So basically, instead of saying if not user input equals who's there, we can say while true. Then we can put that condition down here. And this is to say if the user input is incorrect, we can user input equals input again to have them try to get the input correct this time. Then we can say else, if it is correct, then we can break out the loop, just like that. And so I'm going to jump back and run this to show how it will be implemented when you run it. It says knock knock, I'll say dogs. Nothing happens, it's asking for input again. Notice how it's blocking, because the cursor here is flashing. It's waiting for me to type in a message and press enter. So I'll say cats, I'll say fish, which is all incorrect responses here. But if I say who's there, it moves on. And that's because it keeps checking to see if we put the right thing in, and if we did, it asks us to put input in again. And you can give the user a message when you do this too. You could say, here inside of your input, you could say incorrect input, try again. And this will actually print this message out. This is some added functionality that we didn't know about our input function, but if we put a message inside of our input functions parentheses here, it will print this out, and then it'll ask us to enter something in and press enter. So I'll jump back over here and I'll press up to get the last command, and I'll run this. It says knock knock. I'll say dogs. It says incorrect input. Try again. I'll say cats. Incorrect input. I'll say who's there. And then it goes to the next part of the knock knock joke. So use this implementation to flesh out your knock knock joke more, so that you're not only checking for who's there in the first part, but for the second part, you're checking for the next part of your joke. So that's the end of our loops implementation, and that's your assignment for now, is to modify your knock knock code. And after that, I'll catch you in the next one.